Thanks so much to everyone for joining us today. I'm Rodney Siegel. I'm the Executive Director of the Institute for Bird Populations. And it's my great pleasure today to introduce one of our talented conservation scientists, Jerry Cole. Jerry joined IBP in 2016 as a staff scientist and has subsequently managed a pretty unusually diverse portfolio of field-based and analytical projects for IBP since then. Not only delving into data collection and data analysis for studies of birds, but also branching out and doing the same with bumblebees and even bats. I think this diversity of outputs just reflects Jerry's enthusiasm and really remarkable capacity to jump in and learn new things. And a great example of that in the recent years has been his development of expertise with automated acoustic monitoring, which he'll be talking about today. That automated acoustic monitoring includes both the use of automated or autonomous recording units in bird and wildlife studies, as well as the integration of automated sound classification systems to process and analyze all the data that those automated recording units collect. This has been, with Jerry leading the charge, this has been a big step forward for IBP. We're increasingly using these technologies on lots of diverse projects, often in conjunction with in-person bird surveys. And overall, the incorporation of these technologies is allowing us to increase the efficiency of our work and sometimes to dramatically increase the scope of our work. And I think increasingly even to address questions that we couldn't have reasonably even posed before we started using the technology. So I'm really excited about how this is affecting IBP's work and more generally how it's affecting avian conservation science. So with that, I'm going to turn it over to Jerry to tell us more.
Thanks, Rodney. Okay, we'll see if I can do this in one go. All right, so share screen. All right, and on the presentation. All right, how does that look, Rodney and Meredith, or anyone else? Does that look like it works?
Looks good to me.
All right, cool. All right. Some stuff here. All right, that's great. Okay, well, thanks for that introduction. Thanks, Meredith, for organizing this, and thanks, Rodney, for that really kind introduction. Maybe too kind, but yeah. So today's talk is going to be an introduction to ARUs and AI, as we outlined in the sort of marketing email about this. I'm Jerry Cole. I work at the Institute for Bird Populations, and I figured I'd start off with this. So the background on this slide is something that was generated by an AI. So it was generated by a style GAN is what it's called. So it's essentially pitting two neural networks against each other. So you have one AI that's trying to identify whether or not an image is an illustration of a bird, and then you have another one that's generating a fake illustration of a bird. And this is really early on, just to be fair to the AI, this is very early on in the training process. And you can actually see it's sort of like an abstract representation of a bird. I guess that's being kind to the AI. But yeah, so, AI doesn't always work out immediately, and maybe doesn't work out at all for a lot of different things. But it is interesting to see what it looks like along the way. And so this is an illustration that was generated by Emily Oliver at CogApp. It was a hack day competition. If you want to find out more about that, you can ask me later. But it's really interesting to see all these different applications of AI in art and in science and all other aspects of life too. All right, just to jump in, just give you a little background on what IBP's experience is with ARUs. We started with California State Parks, doing a pilot project with them to really, they were looking for some new technology and how this new technology might apply to their parks. And they thought, hey, maybe we can use acoustic monitoring units to really get an idea of what's in our park and perhaps do it a little bit more easily than what we do now with the in-person surveys. So that's where we started. And then we expanded to working with the Bureau of Land Management in the Mojave Desert. I'll detail that a little bit later on. And for these projects, we've used a mix of wildlife acoustics and audio Moth units. So some of the most expensive units out there and some of the cheapest units out there as well. Not to say that cheap means not high quality. I think audio Moth is quite a high quality product. And then we use Birdnet for automated annotation for I guess all of our projects that we've worked on so far. A little rundown in more detail about each of these projects. So for the California State Parks project, we were working in off-road vehicle areas. This is special designation under California State Parks here in California. And like I said, developing a systematic acoustic survey methodology across multiple parks with the BLM, Bureau of Land Management in the Mojave Desert. The goal with that project was to really understand what bird community were using 2 different sites out there. They didn't really have many bird surveys at all of those areas, and it's actually quite difficult to access them. So using ARUs in that instance was helpful. We have another project in Colorado with Gunnison sage grouse that's just starting up, and that one is to determine lek usage. So with sage grouse, they go out to these areas that have less vegetation and will display there for breeding purposes. We really want to understand the usage of those leks, whether or not they're using a lek, and the frequency and timing of grouse visits. So we're going to try and get that going in the next, this year, I guess. It is 2022. And then with the Park Service, we have some recordings from Olympic National Park that were collected for a different purpose, that we're trying to understand singing phonology of songbird species with respect to elevation and date. And the idea behind that is to apply it to sampling of that park. You know, are we getting out in the right areas at the right time to be able to capture the species that are actually there and not missing them because the singing phonology mismatches with our sampling, our in-person sampling, I should say. So why would you want to stick around for the talk? I'm just going to be upfront with you of what we're going to talk about so you can decide for yourself if you want to stick around or if you want to come back for the question and answer session. So we're going to give a basic understanding of what ARUs are and what they can do for you and your projects that you're working on or that you potentially want to work on. Another piece is an overview of the tools that you can use for processing acoustic data, and that includes artificial intelligence, though I will admit I am not an expert in artificial intelligence. I just use it as a tool. And how these 2 things work together, how do ARUs and AI work together to give you a usable product from that. And then, of course, you can grill me about ARUs at the very end. So just to give a really basic introduction, what is an ARU? What does that actually stand for? And here's audio Moth on the side. That's a type of ARU. There's a couple of different definitions of what the A, R, and U stand for. And even within the literature, people sometimes use a different word: automated recording unit, acoustic recording unit, autonomous recording unit. But in this talk, we're just going to say ARU means acoustic recording device that can be programmed to turn on and off on a daily basis. Let's say that's just the basic setup here. And in this talk, we're going to be mainly focusing on, well, exclusively focusing on bird recordings. So with models of ARUs, I would say there are 4 major manufacturers that exist out there. I'm sure there's probably more that I don't know about, but these are the main ones. And just to give you an idea of the price point of what we're talking about if and when you want to use ARUs for a particular project. So the first one I would talk about is Wildlife Acoustics. These are, I would say, some of the highest end units out there. They have a song meter 4, which is 850, and then the cheapest one they have is the micro, which is 250. Cornell has I would say a recently established program for creating these units that are similar to Wildlife Acoustics or to other ARUs that are out there. It's called the Swift. They also have a Swift 1. The price point is around $250. So quite a bit cheaper than the Wildlife Acoustics. We have Open Acoustic Devices, which created the Audio Moth, which is, I would say, I think it is the least expensive manufactured unit out there that you can use. Depending on what version you get and how you buy it, it's somewhere around $60 to $80. And then these don't come with a case. You can create your own case, or you can use the official case, which is around $40. So you're talking about $100 to $120 all in for that, if you're going to use the case that they produce. And there's another company called Frontier Labs, which is based in Australia, that I haven't ever used before, but it looks really useful as well, and high quality, similar to Wildlife Acoustics. So they have this BAR unit, I think it means bioacoustic recording unit. That's around $700 US. And then they have a really long-term unit called the Solar Bar, which is around $850. And then there's also some ARUs, I guess you could call them ARUs, that come in smaller forms, as in on animal configurations. So on larger animals, you can actually stick a microphone on there and have it record throughout the duration of that animal's life. Well, maybe not within a season, and you can recapture that animal and get the data on vocalization off of it, which is pretty amazing. So just to run down the differences in all those ARU models. So on the right here, I have a DIY solution to create your own ARU using a cell phone and some soldering. It takes a little bit more work than it would with these other units that are manufactured. This is from Donovan and Belantic and their colleagues, where they can actually send out recordings that were collected in the field that day using a cell phone network, upload it to Google Drive, and could even be analyzed that same day as well, which is pretty amazing. But again, it takes a little bit of expertise to create that sort of thing. I would highly recommend checking out that paper. So anyway, the differences between these ARU models I listed before is mainly ease of use versus cost. So Wildlife Acoustics unit, you can program it right in the field. It's super durable, really good support. And as opposed to an Audio Moth, there's great support, community support, but you can't program it in the field without having a laptop out there. But you can set the time and date using your phone. There's a cool app that you can use for that. So those are sort of the trade-offs between the different units. Yeah, like I was saying, Audio Moth is maybe the most customizable solution out of the box. You can solder on different components like an external microphone, a GPS unit, these sorts of things. And Frontier Labs, the solar BAR is amazing. It looks like you could leave it out there for years as long as you have sunlight. And like I said before, DIY solutions exist out there, so you can check out Donovan is one example of that. So the benefits of ARUs, one of them is, I would say one of the main ones is you can sample at optimal times for birds. So that's time of day and day of year. This is another figure that was taken from Belantic and Donovan. They have a lot of great papers out there. It's just an example of, maybe day of year and hour of day, how a given species might vocalize. And then you can set up your ARU to sample according to that. And even Belantic and Donovan have written a paper where they can actually adaptively change the ARU sampling with those cell phone units. You can change it to sample at a different time of day, depending on temperature or weather conditions out there. And given that, you can repeatedly sample with less human effort. So with a point count, we can sometimes only get out to a site maybe 1 or 2 times in a season, but with an ARU, you can have essentially a virtual point count hundreds or thousands of times in a season. And then you have a permanent record. So you have these recordings that you can go back and reprocess again. Another piece that I like of it is that you could rewind a count. So sometimes you're out doing a point count for birds. You'll hear a single vocalization, you don't hear it again. You can't really rewind in your mind and re-listen to that vocalization, but with an ARU, you can, and you can actually compare it to recordings that exist out there. Okay, so those are the pros. Here are some cons of ARUs. I would say one of the biggest ones is it can be an expensive initial investment if you want to get a lot of the units, and if you want to get really expensive units. If you get the Wildlife Acoustics units, if you got 10 of them, that's over $8,000 that we're talking about. As opposed to the Audio Moths, you can get a lot of units for a similar amount of money. So 50 Audio Moths, maybe $7,500. That's a pretty good chunk of change. But I think the benefits in some instances outweigh the cost. Another piece is you have a lot of data. So I would say this is a pro and a con. I know people will say, well, having too much data, that sounds like a good problem to have, but there are pieces of that are difficult to deal with. And I would say the back end of ARUs is one piece that's tough to work with and might require a little bit of technical expertise to store all of that data, query it, and process it if we're talking about in automated methodology. Even if you're talking about in a manual capacity, it's also a lot to deal with. And then often it takes longer to detect a bird than it would this is specifically talking about an automated detection, an automated classifier. It often takes longer for it to detect a bird acoustically than a human might. So you might need longer duration recordings. So we're going to zero in on solutions for having what to do with all of that data that you now have, because you've collected all of it with your ARUs. So one way that people have dealt with it is to subsample recordings. If we're talking about doing manual annotation, is you take a small portion of those recordings and actually have a person listen to them and manually annotate that. But that can take quite a long time. And if you have a lot of recordings, it seems like a shame to not use that. And that's where using a recognizer classifier, essentially software that can go through all of the recordings and say whether or not a species is there, that's where that comes in. And there's a lot of different ways you can, there's a lot of different methods that you can use to go through large portions of your recordings and classify them that exist out there. One of them is Arbamon. It's sort of a cloud-based system where you can upload your recordings and create classifiers and scan through your recordings very quickly. That's from Rainforest Connection. You have Kaleidoscope Pro from Wildlife Acoustics, which can cluster recordings that sound similar together, and then a human can intervene and say, oh, these are all common yellowthroat or whatever species we're talking about. Another one is Birdnet, which we will talk about more in detail later on, from Cornell Lab of Ornithology. AM monitor package is great for inside of R if you're doing your data processing there, from Valantic and Donovan again, showing up. We have a monitor package, a warbler package. There's plenty more packages out there and softwares out there that you could use to do this sort of thing. But in this case, we're going to talk about Birdnet because that's what we've used and have experience with. So when you use Birdnet for acoustic processing, you're using something that's created by the Cornell Lab of Ornithology in collaboration with Stefan Kahl. I apologize, Stefan, if I am butchering your name, from Chemnitz University of Technology in Germany. And there have been some papers that have been published on this call. Published one in 2021, and Connor Wood also had one in 2021, so I would recommend checking those out. So the initial version could identify around 1,000 species from North America and Europe, and the new version can ID over 3,000 species. I'm sure it's even more now. And it's freely available. I would highly recommend checking out birdnet.cornell.edu or even just Googling Birdnet Cornell, and there's an excellent website there. You can, there's also an app that you can download for your iPhone or Android that's free. And, but the website's great. There's all sorts of cool activities you can try out there and contact information for the creators of Birdnet. I should say that I have no association at all with Cornell Lab of Ornithology or the Birdnet project. I'm just a user of it, and I really appreciate it. So how is Birdnet trained? Essentially, so Birdnet, this is where we get into the AI part of it. So Birdnet is a convolutional neural network. What that means is it takes in a bunch of labeled sound clips from Macaulay Library and Xenocanto. These are two of the major databases that exist out there for bird sound. And these are labeled. So Xenocanto, oftentimes I would say it's weakly labeled. So you have a foreground species that you know is vocalizing, and then you have some background species. And it can take all of this information in. It essentially turns a sound into an image, so a spectrogram, a visual representation of sound. And then it trains a model to look for patterns in the sound that can identify a given species. It uses a convolutional neural network. It's essentially just a flavor of artificial intelligence that's quite good at pattern recognition. If you, I'm sure there's apps out there where you can, is this a cat or is this not a cat? That's could be a convolutional neural network that was trained by Google using all of these images that exist out there. And it's really good at generalizing across lots of different sound types, as opposed to another type of classifier, which is called the template classifier, which uses a very stereotypical sound that you're searching for in your recordings. For instance, like chickadee sound, chickadee-dee-dee. If you're looking for that sound, that template would go in. It would essentially scan through all of your recordings, and anything that looked similar to that sound would have a hit, a very strong hit. But with Birdnet, it can pick up all varieties of Birdnet all varieties of chickadee vocalizations that were included in these Macaulay librarians, Canto databases, rather than just a single one. So I stole this from the Birdnet website. It's an excellent visualization. So I apologize, Cornell, if you're upset about that, but it's great. It's a great tool. Again, check out their website. So this is just gives an idea of how the workspace might flow. So you have your audio recording data that you got from your ARUs plus metadata. So that means geographic location and perhaps date of sampling. It's converted into a spectrogram. So that's what that black and white image is on the upper right-hand side. Feed it into Birdnet. Then Birdnet spits out the top 3 species that it believes are on that recording, and then confidence scores for them. So essentially, how confident is Birdnet in its identifications? And in this particular instance, Northern Cardinal, it's 91% confident that's what's vocalizing in the recording. And then it can move through eBird occurrence mask there, which is the next part of the flow. Essentially, what it does is it can take your geographic location, query the eBird data and say what species should be in this location, and then it can filter out anything that's strange. So for instance, maybe there's Birdnet identified some European species that probably isn't there. It will get taken out of that final product. And then we get a text file at the end that we can use for further analysis. So I'm just going to give a little rundown of how we've used Birdnet in one instance. So one project that we've worked on, like I said before, was with the Bureau of Land Management near the Mojave Desert. So we had some sampling on the west side of Death Valley and then up a little bit farther north, also sort of in the desert, not exactly in the Mojave Desert, more like Great Basin. And this is an example of one of the units in the wild. Have a rock cairn stacked up with a U-post stuck in there because the ground is very hard, but we managed to make it work. So we collected over 25,000 hours of recordings out there. We used these audio Moth units that were slightly modified. We pulled off the AA battery pack on the back, soldered on a D battery pack for longer life, and then put them in one of these, I'm trying to think of what it would be called, a junction box probably, that you can just buy off of Amazon, and they seal up pretty well. And then we have a sound permeable membrane that doesn't let any moisture in, but also lets sound pass through to the mic on the audio Moth. We took all this data that we collected and processed it using Birdnet, using Google Cloud Platform. Since Birdnet is Python-based software, it's sometimes useful to use a cloud-based service, because if you don't want to have your computer running, trying to process the data, you could potentially just put it up on the cloud. You can put your recordings on Google Drive, and then you can have Google Cloud Platform query those recordings and process them with Birdnet and then spit them back out again, all while you're sleeping or doing whatever else you want to do without your computer melting down. And then we took all this data and filtered it to high confidence scores. So if we go reflect back to that previous slide where we're showing the Northern Cardinal was the highest confidence, by high confidence, we say maybe greater than 90% confidence by Birdnet. And then we can verify a portion of these recordings, not all of them, because from our 25,000 hours of recordings, that's millions of Birdnet hits. What we did is we verified 100 of the highest confidence detections. And then from that, we can identify an optimal confidence score. So one that limits the number of false positives. We can also identify precision, essentially a metric of how many false positives there are in the data out of all of the positives from Birdnet. And then we can filter the remainder of the detections using that threshold. So we can go through 100 of the recordings, and then we can figure out what of the thousands of hits for a given species are good enough to use in further analysis. And this isn't something that's super new. It's just an application of things that people have done with other automated classifiers in the past as well. So this is just a demonstration of what you might do with the Birdnet output. In Call's paper, he did something similar to this as well, seeing sort of the phonology of singing through time near Cornell's lab up in Ithaca. And just to orient you to this plot, so the 0 to 1 on the y-axis is a normalized index of acoustic activity. In essence, what that means is the number of Birdnet hits per week of our sampling. And so 1 is the maximum number of hits over our course of sampling, and 0 means no hits. And somewhere in between is just a proportion of that maximum. And then 2 different colors. The solid pink line is for Cottonwood Creek. That's the more northerly site of our Mojave sampling. And then the dotted line is Surprise Canyon, which is the more southern site on the west side of Death Valley. And with this, you can see some interesting patterns. I mean, I'm not exactly sure what to make of it, but you can see some interesting patterns. For instance, spotted towhee, the peak of acoustic activity is a bit different between these 2 sites. Black-headed grosbeak, it's slightly different as well. And I don't know, I think this is really interesting information that you could get using these acoustic units being out there for quite a long period of time. Something similar to actually what I think we get from eBird with these bar plots or even the predictive maps. And we'll talk about that a little bit later. So there are some drawbacks of Birdnet. And I think this also applies to any classifier really, which is that performance can be dependent on environmental noise and the quality of your recording. So if you have a better mic, a better setup, less noisy setup, not as much wind, Birdnet does better. That's pretty straightforward. Verification can be time consuming if you have a really large community, if you have hundreds of bird species that you're trying to deal with. If you're trying to verify 100 of them, that can add up, but it seems like it's worth it for the amount of data that you get for that effort. So again, for richness, it's probably helpful, and I would say you would want to do it almost all the time to verify a small portion of those detections from Birdnet to make sure that what you're getting is high enough quality for your purpose. And again, longer duration of audio sampling is needed, so you might need to think about data storage problems. And this is just an example of how long it might take for Birdnet to detect a species at a proportion of sites that a human also detected when annotating the same recordings. And you can see for some species, it doesn't ever reach. So 0 to 1, 0 is none of the sites with human detections where it had a Birdnet detection. 1 means 100% of sites had a Birdnet detection and a human detection. So some of these species, we don't ever get up to 100. I think with longer sampling, perhaps you could. Anyway, the moral of the story here is that longer sampling is better if you're trying to pick up a species, which I think most of us already knew that. So benefits of Birdnet, one of the big ones is you can detect a really large number of species without having to build your own classifier, which is kind of what we've done in the past for most of classifiers history. That's kind of what we've done. It's been a single species or a couple of species that have been you built a classifier for, and that's what you used it for, as opposed to a huge community. And now you can do that with a lot less effort because of Birdnet. And what another thing you can do is you can process a lot of data. You can use all of the data instead of having to subset it. And hopefully that means less human effort. At least it's less human effort of going out in the field. So this is my wish list of features that I think it would be great for Birdnet to have. And I'm sure Cornell's probably already working on this, but these are just things that I just wanted to put out there and say, hey, maybe this would be interesting to try and create. I think it'd be great to be able to separate different types of bird vocalization, songs versus calls. Right now, Birdnet just gives you a hit that says a species is there regardless of what type of vocalization it is. And that could be helpful for phenological purposes, I think. If singing is a metric of perhaps breeding activity, then it might be helpful to use only songs versus calls rather than all of it mixed together. Cloud interface for data storage and processing would be great, similar to how Arbamon works, or even Wildlife Acoustics Kaleidoscope Pro has a cloud version too, where you can do that. Maybe an integrated interface for verification of Birdnet detections, perhaps thresholds for different species. So figuring out what confidence score you might want to use to be pretty confident that you're getting mostly true positives. And maybe a way to submit feedback to the Birdnet system. There's already a way to do that with the apps that exist for the phones, but I don't know of a way to do that with the Python version. So all of that said, when do ARUs and Birdnet work well? I think these two things mixed together work really well in areas that are hard to access. So if you can only get out there twice a year, you can leave the unit out there and then it can collect all of this data, and then we can deal with all of this data by using Birdnet. So that's where it really shines, I think. And with species with low detection. So if you can only go out to a site once and a species doesn't vocalize that frequently or is hard to detect, it's really helpful to have a really long sampling frame. And then you can use Birdnet to process all of that data to look for something. Another instance, maybe this is a little bit more specific to me in what I've dealt with, is you could use it in instances where staff have limited bird ID expertise or time for learning that, or time for even processing data that's derived from acoustic units. So what you could do is you could have someone go out and put out these units that isn't even trained in bird identification at all, and then they could bring back the recordings. Even if you don't use Birdnet, you could have an expert annotator annotate the recordings for them and then give them an idea of what bird community is there. But with Birdnet, you may be able to do that and give them even more because you can process a larger volume of data. Another piece of this is if you want an understanding of acoustic phonology, maybe I just have that on my brain, but it seems like it's a great tool for that because you can process vast amounts of data. I think for being able to understand acoustic phonology, you need that continuous data to really see where the changes happen rather than getting these small little snippets that you might only get by using manual annotation. So what's next with the Birdnet research, or where would I like to see Birdnet research go? Not that I'm in control of it, but I think another piece of it would be understanding migratory phonology. So we have these cool maps that were put out by Cornell using eBird data. These are predictive. This is predictive modeling using eBird data to really understand the movement through space and time of bird species. This is just an example for Say's phoebe. And what you can actually do is you can use the eBird ST package in R to query a single cell if you want to essentially make a line plot of how a cell changes through time. So going from yellow to purple across the months. And what we can do is we can take this, in Call's paper, he did something similar to this as well, except using very localized data, not predicted data. So this is from Surprise Canyon on the west side of Death Valley. And these are similar plots to what I was showing you before, except this time we have these eBird predictions of abundance through time, and they're scaled again. So 1 is max and maximum abundance, and 0 is no birds there. And we can sort of compare these to what the output is that we got from Birdnet. And it's really cool that for some of these, they line up almost perfectly. It's almost eerie. So for the black-headed grosbeak, we see a almost perfect lineup. But another thing to remember with these is, I would say neither of these is truth. And also, there are two different types of sampling methods. eBird is using visual and auditory detections, and Birdnet is all auditory, right? So that might explain some of the variation and differences in these curves that we see. But all that said, I think it would be really interesting and great to have a huge network of acoustic devices that exist out there, maybe in people's backyards, that are systematically sampling, even more systematically than eBird data, systematically collect acoustic data and then process it through Birdnet, and you can get similar plots to what we get using the eBird data. So, and this is really useful even for a single site too. You can get these cool plots, like this is just data from a single 15 or 20 units along a reach of a creek. Okay, another piece would be having multi-year deployments for detecting shifts in phonology. So Justin Kitts had a paper in Ecosphere talking about how it might be useful to put automated units, not just recorders, but cameras, these other things for detecting wildlife at NEON sites, the observatory out in North America here, that's run by NSF. Another piece is coupling ARUs with human surveys. Dozer had a great paper on that, so you can get even more data when you do it that way. Another piece might be, does Birdnet data match telemetry data? So if we know where birds are on the landscape, we can sort of compare that data to what we get from this acoustic data that is processed with Birdnet. And it's really, it would be interesting to see the differences between those two things. And then adapting existing modeling frameworks, for instance, occupancy modeling, for using ARU data and automated detection data, and we have a paper in Press It, Ornithological Applications, doing that. I would like to thank Nicole Michael from National Audubon Society. She's been a great partner in all of this from the very beginning, working with California State Parks and using the ARUs, among other things. Shane Emerson is our contact at California State Parks, who has helped us with the ARU project. Clint Helms at BLM for helping us with the Mojave project and getting us out there and being really excited about it. Steve Albert for helping us get funding for all of these projects, and Connor Wood at the Cornell Lab of Ornithology, who's heading up a lot of these questions that I'm asking, you know, understanding how to model Birdnet data for answering ecological questions. So thank Connor for answering some of my questions about that and continuing to work hard on moving Birdnet into the future. And with that, I will take any questions. I went a little bit long, but hopefully it was useful. I'll see if I can stop sharing here now.
Hi. Okay, so I've been recording the questions from the chat, and so we'll start going through those, and feel free to pose more questions in the chat if you think of something as we're talking, and depending on how many people are left at the end, we may just open up the audio. But all right, let's go to the first question from AR Kornreich. How do recognizers / classifiers handle instances of mimicry, for example, from mimids like northern mockingbirds or gray catbirds?
Yeah, that's a good question. I don't really know the answer to it, but I suspect it could be tricked depending on how good the mimic is. Yeah, that might be a better question for the Birdnet folks. You can, like I said, you can go to the Birdnet website and ask them questions. They have a nice contact email there. But yeah, I haven't tried that before. That would be an interesting question to understand. But no, I can't answer that.
Okay. So this is a question from Matt. I get it's kind of two-part. Why did you use the junction box cases versus audio moths case? And in cases where you've used audio moths cases, have you reduced detection of low frequency sounds such as owls, as some people have?
So that's two parts. The first part, the reason I use the junction boxes is because with the battery pack that I put on there, it was too large to fit in the official audio moth case. There is no case that would fit there is no standard case that would fit the size of the audio moth that I had. That's why. And oh yes, the frequency question. Yeah, there is some loss of lower frequency. I haven't really tried it with owls, but I think the official cases are probably as good as you're going to get for a waterproof case. I mean, the patch that's on there is super high quality. I don't think you could get any better than that, unless maybe you put it in a bag. Maybe you get better sound transmission, but I think it's probably as good as you're going to get.
Okay. This is from Dan. Does Birdnet only ID your top 3 most common species, or can you tell it what species you were looking for?
Yeah. Yes. So yes to both. You can let it stay at default, and it'll give you the top 3 species. You can also, there probably is a way to modify it to give it a list of species to only pick from, to say only look at these species and that's it. That's in essence, I mean, maybe I'm a little bit wrong here, but that's in essence what happens with the eBird filter, is it filters down to a suite of species that are detected within I think a half lat, half long degree cell of where your GPS point is. So that's essentially what happens. But yeah, I think that is something to be, that I didn't include that, but that is something that I would recommend highly, is limiting the number of species that it's trying to identify, because you could come up with lots of data that is just spurious. Yeah, that's it.
Great. So a question from Robin: how does one get the Python non-mobile device app version of Birdnet?
Yeah, so you can get it off of GitHub. So I would say go to the Birdnet website, the birdnet.cornell, or you can just search Birdnet Cornell, and you'll see, I think on the first page there's a little link to the GitHub page, and you can pull the repository onto your personal computer, or you can pull it onto a cloud service as well. And again, I would say if you have trouble with that, you might contact, there's a good contact email for the Birdnet folks on the bottom of the page, I think.
Okay. Let's see. Another question from Matt. Are your protocols for all of this work, including field surveys and especially the data processing component, available publicly or upon request for interested people? I'm especially curious about processing with Google Cloud and any associated cost.
Yeah, they are not currently available publicly, but I would be happy to try and share it with you and talk with you about it. Yeah, it can be a little tricky setting that up. So the other question was, oh, right. The other question was about cost. So the way that I have it set up right now with Google Cloud, the processing, it costs about 7 cents per hour of recording, though I'm sure someone who's more well-versed in cloud services and multiprocessor technology could cut it way down. And again, I think I'm shunting too many of these questions to the Birdnet folks, but they say that they're open to collaboration. And if you have any questions, technical questions about how to do things like that, like process large volumes of data, you're welcome to contact them.
I just want to note that for folks that were interested about the MIMIDS question, there's some discussion in the chat about it from Matt and a couple of other comments about using different cases or AM monitor on R for wood frogs. So go look over there. They're not exactly questions, so I'm not going to ask them, but if you're interested,
okay. Yeah, that's good.
Okay, next question. Robin was wondering, is it possible to determine numbers of individuals of a species from recordings?
Yeah. Yeah, people have done some work with that. It's a little tricky. Yeah, so the Dozer paper that I was talking about, DOSER, that paper is actually trying to get at density of individuals of a species. And that's the way that works is you have one human survey and you have the ARUs, and some of them overlap, though I don't necessarily think that has to be the case. But yeah, Dozer says that you can get density from that. And then there's other pieces too, where maybe you could have some sort of connection. There's some research on call rate. So how frequently, maybe you could have some sort of connection between how many Birdnet hits you get per whatever, let's say per minute or per hour, might have some connection to the density of that species there. But I haven't really seen any papers that for Birdnet specifically that have linked to those two things yet. So I think that's somewhat of an open question with regard to Birdnet.
Okay. Yeah, and Jamie later on in the chat asked a very similar question, which I think this answered, the quantitative data versus presence absence. So I think we covered her question.
Yep.
Travis was wondering, have you heard of anyone using ARUs to collect both bird and bat calls simultaneously? Can a single audio moth, for example, accept audio from 2 different microphones?
Oh, from 2 different microphones. I'm not sure if they could accept audio from 2 different microphones. The only way that I think it only does mono. I think it only accepts one mic input, but I could be wrong.
I've experimented with this a little bit, trying to do bats and birds and frogs. The main issue is that the frequency to record bats, which is like 384 hertz, is so much higher than what you need for birds that it burns out the battery and fills the space up like 10 times faster. So if you have them set for bats, you can't get that long window of recording time. It just takes up way too much battery.
Right. Yeah, that makes sense. Yeah. So, and another thing with the audio moths, I think there's a like threshold with the newer firmware. I think there's a thresholding too. So yeah, like Kevin said, I think you might be relegated to having 2 audio moths out, like one for birds and then maybe one for bats. And perhaps you could use some sort of thresholding. So there's a thing where you can, if it's above a certain essentially loudness, then it will keep that recording. And if not, it won't keep it. but I guess that doesn't deal with the battery problem.
Okay. So we have a question from Sarah, asks, since Birdnet doesn't identify specific songs/calls, do you have a recommendation for a program that does, preferably one that is free?
Yeah, free is always good. Well, so a pre-made one, there are not many out there, I don't think. I would say Arbamont, as far as free goes, I would say Arbamont seems pretty good from Rainforest Connection, and you can sort of build your own classifier there to try and pick up a very specific song type or call or something like that. And template classifiers too. I think AM monitor, I think those have the ability to do that as well for free. So
Cool. Barbara asked, do you have any reservations about the reliability of Birdnet identifications?
Yeah, I mean, every classifier for sure. I have some reservations. So yeah, it just sort of depends. I think, like I said, I would do verification of every species, at least do some, and then you would get an idea of how well it's working for your species, for whatever ARU you're using, and whatever your environment is like. I think it can be pretty variable depending on how good your recordings are, how much noise there is. Yeah, it can vary, and even the species, it can vary too. So I think verification of Birdnet detections is, I don't know, I wouldn't say it's required, but I would highly suggest it. That's my answer to how to deal with the problems. But in general, I would say Birdnet has worked pretty well for me personally.
Great. And then we have a question about, is it possible to use this methodology to monitor how noise affects birds in their ecology?
Yeah, I would think so. I mean, so that's one of the things I was interested in initially with using ARUs, was with these state vehicle recreation areas. That essentially means four-wheel drive vehicles, areas that are open to four-wheel drive vehicles, but there's still habitat nearby. And yeah, that's one of the questions I was interested in was, I mean, maybe this isn't exactly what you're asking, but I was interested in understanding, do they stop vocalizing? Maybe it's hard to say with acoustics, right? Whether they leave the area or they just stop vocalizing, but just the patterns in vocalization in response to some sort of trigger, like a vehicle passing, or is there a certain sound level that makes them leave an area completely? So those sorts of questions. And then, I mean, something that's even more detailed would be changing, you know, there's been research on birds changing the frequency of their singing as well in response to for instance, traffic noise that's just a continuous presence in the environment. They've shifted their frequency. So yeah, you could perhaps do that too with using ARUs. I don't know, maybe hopefully that answers your question.
So there's some good discussion going on in the chat. I don't see any questions that I've missed, but if I have, let me know. But if anybody has a question, they just want to turn on their mic and ask right now, we can do that for a little bit because we got some time. So
yeah.
And if not, if you think of something later on, I'm sure that Jerry would be happy to answer emails.
Yeah, sure. That's
come
great.
up with one. We'll also get this. Sorry.
Looks like Ken has a question.
Oh
yeah. Hi, Jerry. So I'm just wondering if you or anyone else has used this technology to look at the effect of observer presence on bird vocalizations.
No, I haven't looked at it. I have a feeling there are papers out there that do talk about this, but yeah, I think that would be a great question to ask, right? Because I think that's one of the questions people have about point counts is, you know, there's the like cool down period that people sometimes do of waiting 5 minutes until they start recording birds out there. But yeah, I think that would be a great question to answer. I'm not sure if it has been answered yet, but it's a good question.
I'll just say I put a link to an audio Moth case, a 3D printed one, in the chat that I've had great luck with. We had out 65 in Vermont this spring. I don't think any of them leaked. So that was a really good option. You could buy basically that same acoustic membrane wholesale on like Alibaba or some one of those sites. So just want to add +1 in for that case in case anyone wanted to explore with it.
Nice. Yeah, thanks, Kevin. Yeah, I'm always looking for new cases and different varieties of cases to see if they'll work. Yeah, I think with acoustic membrane too, I think on group gets, I believe they now have a way that you can buy individual acoustic membranes that are the same ones they use for the official audio Moth cases, and you can just buy the membrane itself. That was one problem I was having, was trying to, I too went to Alibaba to try and find membranes, but it's hard to know what the quality is on there. So
yeah, and you get hit with like a $25 shipping fee for a $10 item. So.
Yeah, exactly. And a lot of places like those really high quality membranes they use for the official cases, I went to the supplier, their supplier, and they won't deal with you because it's such a small quantity. They don't even want to work with you. So it's good that they have it on group kits now.
Jerry, this is Dan. I had a question for you. I've used Kaleidoscope, and we're looking for specific species like northern goshawk, boreal owls. There's a bit of a knack to being able to write or produce the classifiers that are needed for doing that. Do you know, is there anywhere there's like a sharing point, a library of classifiers that could be shared amongst biologists?
Well, so I think, I could be wrong, but I think on Arbamon, I don't know about for Kaleidoscope, but on Arbamon, I think that's what one of the things they're trying to include on there is sort of a searchable database of classifiers.
Oh.
Of course, you'd have to shift over to using that system, and it's still, I mean, it's good. It's pretty good. It's a little clunky, a little slow for some things, but yeah, I would say check out Arbamon from Rainforest Connection. There aren't tons of classifiers that exist publicly, but I think there are some.
Great, thank you.
Mm-hmm.
Looks like Matt had a question in the chat. For people who are having issues with membrane damage on audio Moth cases, any idea why it's happening? I'm thinking of putting an audio Moth inside a metal suet cage to keep out mammals, but not totally sure mammals are the issue.
Yeah, I don't know. My guess is probably as good as anybody's guess. I have seen people claim that, yeah, that mammals will go up and like bite the membrane, but yeah, I don't know. People have done what you're saying, where put a metal cage over top of it, which it seems like that wouldn't impede sound very much, depending on the size of the mesh. So yeah, I don't know. Sometimes if it's like really, I think if it's really extreme temperature change, oh, maybe Kevin knows too, but if it's a really extreme temperature change, that might pop the membrane because it's like changing pressure too quickly. But I don't know. Maybe I'll let Kevin speak and see if he has something to say about that.
We've had a couple cases bust a membrane. I always thought it was because someone might have accidentally rubbed it against bark and just punctured it a little bit. But yeah, definitely the pressure change might make sense depending where you are or the time of year you have it out. I haven't tried the open acoustic official audio Moth cases, so I just don't have experience with that.
All right, thanks.
Well, I think we're getting close to time. If anybody, Jamie said, you mentioned a software download site recommended for the PC version of Birdnet. Could you please repeat that?
Yeah, I can put it in the chat, but what you could do is just go to cornell.birdnet.edu or some, oh man, that's not the right site. And anyway, you could, yeah, let me see if I can put that in the chat, the link for it. I think I have it on my favorites here. But other than that, yeah, I won't hold up everybody for for me to find the link, but I'll definitely put it in the chat.
Oh, looks like Jenna might have put it on.
Yep, that's it. So that's Birdnet. That's a Birdnet Light repository. There's also another one that's an older version that I've used before. But yeah, you can just go to that CAST GitHub repository and check it out.
Yeah, and someone asked this question in the chat earlier. Since there's been some great comments in here and links that you guys have shared with each other, I'm going to post the chat along with the transcript of the chat along with the video once we get that up on our website, so you can go in and see all this info.
Yeah, well, thanks everyone for listening and sharing all your insights. I appreciate it. It's been fun. It's always fun to talk about this stuff.
Thanks, Jerry, for a great presentation.
Yeah, my pleasure. All right, see you, folks.
Well.